I'm a teacher Limboka Sidiga Masami. Welcome to Limboka Physics. We will use these questions to just see how the concept of simple microscope is explained, and we finally arrive into some two important conditions, which is positions of convex lens which is closest to an object, and the positions where the convex lens will be at the farthest point from an object. And these two conditions will give us maximum and minimum angular magnification respective for this simple microscope. Remember, simple microscope is just a simple, just a single thin convex lens of a given focal length. Here from our questions, we have 5 centimeter focal length for the convex lens. But here student is want to read the words that has got small fonts by using this simple microscope, but his or her near point is 25 centimeter. Let us consider the diagrams for unaided eyes when he or she reads the words with a naked eyes. And this is the words or objects, and this is the rays that enter through eye and produce an image. And the image is very small because the font here is very small, and the eyes of the students want to further continue to focus this small words. And therefore, for figure A, this is the visual angle with unaided eyes, visual angle for unaided eyes, and the relationship between this height of the object and this normal near point distance, a capital D, is equal with we use tan to get the relationship for a small angles. And remember, this D is positive because this is real object. And for the case when this student used this convex lens, she will take this convex lens along this principal axis towards the object O, this wedge, until the object O is between the focal points of this lens and its optical center. Remember, the eyes of the observer must be close to this eyepiece. This is act as the simple magnifying glass or simple microscope. The image object is taken to a distance D near normal point. This distance D, remember, for an adult, the eyes is always able to see an object in a distinguished manner or distinct. And so therefore, always you must make sure that your simple magnifier will take this object into a distance D by changing the positions between the focal length and its optical center with respect to the object. Therefore, the final image, which is magnified and behind the object, is formed at this D. From here, we'll have the closest distance of this object or this wedge from the lens. Therefore, we asked to find this closest distance as from our question. Closest distance students can read when viewing through the magnifying glass. Okay, remember, this image will act as second object, which will be clearly focused by the human eyes, and with no difficult, because now the words will appear to be very large in size compared to the while it is its original size, from its original size. Okay, figure B, simple microscope at normal use. Image is at near point. Remember, simple microscope to form to be at its normal use, the image is always formed at its near point, which is 25 centimeter. Therefore, let us use a thin lens formula to calculate the closest distance of a lens from the object, the words. The closest distance will be obtained from the thin lens formula, as you can see here. Remember, this V is equal to this D, and this D here is negative because this is visual image. Now is equal to positive 4.2 centimeter approximately. And at these conditions, we say that the eyes is accommodated and undergoing the most strains, not relaxed, because at this because the rays the final image, the image which is act as the final object, will appear to come from near distance D. At near distance D's, rays will cause the ciliary muscles and subspecial ligament to contract. As it contracts, it's pushing the eyeballs up and pushing the eyeballs down and causing the eyeballs to increase in diameter along the horizontal axis. Therefore, the change in increase in diameter from its original diameter is always resulting to the most strain, the greatest strains of these eyeballs, as the observer focusing the near point object now, which is this image, and therefore the eyes tend to decrease its focal length while it forms the image on the retina. And therefore, for the case A, and the concept of closest distance, that is going with hand with the maximum magnifications. Here is angular magnification. Therefore, how to find this angular magnifications? Angular magnification is equal to the ratio of angle subtended by unaided eyes to the angle subtended by aided eyes, as you can see here. Remember that we know the relationship for subtended with aided eyes. As you can see, this is opposite and this is adjacent. The tan of this theta dash is approximately equal to theta, which is equal for a small angle, which is equal to h dash divided by d. Then d and d is cancelled out when you consider the mathematics here. Therefore, we will have the ratio, which is height for image to height for object, and this ratio, we know from the definition of magnifications, which is linear magnification, is equal to distance for image to the distance for object. And from this thin lens formula, so we multiply with v in both sides, then we know that the ratio of v to u is equal to magnification. Then we take this one in left right sides, and then we replace this v with capital D. As you can see, this is the distance for image. Now, after replacing with capital D, remember this capital D here is negative because this is a visual image. And for this case, we substitute our data. We have 25 centimeter for focal length, which is 5 centimeter. Then our final answer is 60. This is our maximum angular magnifications when the lens is taken close to the object and forms a final image at a near point D. Now, for the second case is when the farthest distance the students can read when viewing through the magnifying glass. The farthest distance now we consider as the case where the initial position of the eyes of the observer is taken until the object is at a convex lens focal points, as a convex lens focal points. At this point is where the image of this object is upright and formed at infinity, and the top of image, as you can see here, and its image distance is at infinity. Remember now, the farthest distance the object can be, the words can be placed is where is at a focal point, and its distance is equal to focal length of this lens. And for this case, we say that the eyes is unaccommodated, and or it is said to be at rest. And for this case, we say that there is a least strains in a human eyes, mostly relaxed at this state, where the eye is most relaxed. As you can see here, we say that whenever the rays of an object is come from the far distance, now the image is formed at the far distance. This image is acting as a second object, the final object that will be focused by the eyes to the retina, so that to get the perceptions of this image or this object. Now the ciliary muscles and the suspensor ligaments will relax. After getting relaxed, the eyes will be pulled downward, and eyeballs is pulled downward and pulled upwards. Therefore, the curvature of the eyeball is decreased, as you can see that its diameter or radius is decreased. Therefore, the strains here is very, very little, and that's why it is in negative sense, because at first it is at this dotted line, but after focusing the image which is usually as a object, final object, which comes from far, the ciliary muscles and the ciliary suspensor ligaments tend to relax, and causing the eyeball to increase along the vertical. Therefore, under these conditions, the focal length of the eyeballs is increased. Focal length of the eyeball is increased, and we say that the eyes is at a most relaxed state. Okay, thanks for. And for this case, sorry, I forget to find the angular magnification, and we know that the distance now, the farthest distance now is equal to focal length, which is equal to 5 centimeter. At angular magnification, we know that we have the visual angle which subtending this image, which is theta dash, and the relationship connecting the height of this object. Remember, this is still h of the object to the focal length is for tan, and for small angle is h divided. Now, this h and this h is cancelled out, and we remain with d divided by f, focal length of this convex lens. This d, remember, is positive because this is d from a normal near points when eye is with an aided eyes, that is the first case. Now this result into a minimum angular magnifications, and when we substitute f is equal to positive 5 for convex lens, and d, which is equal to positive 25 centimeter, then our answer is equal to positive 5. Now the minimum angular magnifications is 5, and there's a farthest distance where the convex lens or simple lens will be taken, so as the image will be focused into an eyes of the students is equal to 5 centimeter. Okay, thanks for watching. Please like, share, comment. Don't forget to subscribe this channel for more videos like this one. Thank you.